Hello, thanks for joining us for 7:30 South Australia. I'm Simon Royal. This weekend, police are continuing their search in Coober Pedy in an attempt to solve the mysterious disappearance of a teenager more than 20 years ago. As is so often the case in serious crime investigation, the use of DNA could be critical to a result. But the techniques around the gathering and analysis of DNA continue to be refined, including two significant breakthroughs by scientists at Flinders University, as Mike Sexton reports.
It's a familiar event on our screens. Police across the country displaying hauls of illicit drugs and explaining the measures criminals take to hide them.
It continues to amaze us the kind of concealments that we see these things through. Things like electrical equipment, homewares, liquids, all sorts of concealments.
As impressive as the drug seizures are, they're only part of the investigation. Police often round up the minnows who transport the drugs. What they need is evidence to catch the big fish, those making and distributing the narcotics.
Police are often asking whether different seizures can be related. They might have come from the same clandestine laboratory.
This is where forensic science comes into play, by providing evidence to help build a case. They do it by finding clues inside the narcotics themselves.
Within drugs, it's known in the past that there's lots of chemicals that allow one to identify where the drugs have come from. For example, Southwest Asian heroin is different to Southeast Asian heroin, and one can pick the difference chemically.
But a former chief scientist of the Australian Federal Police, Paul Kirkbride, thought there could be more information to be gathered, specifically if there was DNA embedded in the drugs. In other words, is it possible whoever made the drugs inadvertently left a biological calling card?
Nobody really knew whether illicit drugs contained DNA or whether they were devoid of DNA. So the real breakthrough was firstly to find that there was DNA there, and then to try and develop a sequencing process so that information can be got from that DNA to allow provenancing, identifying where the drug might have come from, and identifying whether seizures are linked to each other.
And this is the biologist given the task, Flinders University Emeritus Professor Lee Burgoyne, who's been cracking scientific puzzles for more than 50 years.
I like science for science's sake. Some people play basketball just for fun. I do science just for fun. And it's very, very nice if it has practical application.
The practical application may come later, but for the moment, Lee Burgoyne has proven it's possible to extract DNA from drugs. And his research shows a remarkable list of impurities from soil to viruses.
Animal, fur, dirt from the floor, often a lot of DNA from the people who handled it. They've been sneezing and coughing over it and dropping hair into it. So you can pick up, perhaps one of the problems is when you look at it, you often pick up 2 or 3 or 4 people's DNA, and that's difficult to unravel. If they're going to dirty it, tell them, please, one at a time.
We might be able to recover from the drug seizures the DNA profile of the trafficker himself or herself. And that could be interrogated against a database. We might get a name for the police, and they can go and then investigate that person further.
For Forensic Science SA, the incremental breakthrough is significant. After crimes are committed, its role is to provide independent scientific evidence for the justice system.
Forensic science is an applied science, so our knowledge and techniques come out of the fundamental sciences, biology, physics and chemistry. And in our daily work we're using aspects of molecular biology, genetics, some statistics, a number of analytical chemistry techniques, some organic, some inorganic. And so we're looking for the edge wherever we can get it.
The information gained from DNA has been one of the great advances in this field, but the scientists can't begin their analysis unless they have good samples to work with, which is where Flinders University has again made a technical breakthrough that could streamline the collection of DNA.
The name of the game was to make life simple, direct and unmysterious. We do not need lots of reverence for DNA collection and DNA technology. Sod reverence.
The dreadful reality of disasters such as the Boston bombing is that enormous amounts of DNA must be collected from the scene to identify victims. Currently, this lengthy process involves taking samples of tissue. But Lee Burgoyne has pioneered a technique where investigators use a red-hot piece of wire, quartz rod or even pencil lead to gather data at a much faster rate.
Jab it into the flesh or the blood, take it out, there's sort of soft hiss as you do that, and then you break it off into a very small tube of isopropanol. Now you can take that back to the laboratory by aircraft and it'll weigh all of quarter of a kilo to take back hundreds of samples. And back in the laboratory they just shake off the isopropanol, dry it, drop it, pencil, lead, wire or quartz and all into the PCR reaction mixture, and you've got your DNA profile.
One of the issues around the DNA analysis process is that there's a front-end extraction process where we're looking to extract the DNA out of the sample type, and depending on the type of sample that can take between 3 and 6 hours to do. So anything that will remove the extraction process or simplify that process is of interest to forensic science.
At this stage, both DNA procedures are only at the proof of concept stage, but the work is significant enough to be recognised at the recent National Forensic Science Awards. For Lee Burgoyne, the satisfaction is not in awards, but in finding another scientific puzzle to crack, and in doing so, creating a practical application.
The sods who break the law should be tracked down to the best of our ability. So that's the applied satisfaction, but there's also the scientific satisfaction of developing ways of working through vast amounts of life sequences and pulling out the information you want.